Welcome to Phorge Mathematics. I'm Ryan, and today we're starting with the very beginning of Algebra 1 with understanding real numbers and the number sets. This video will help you build the basic foundation of understanding numbers, so let's go ahead and dive in.
Phorge.
Okay, so by the end of this video, you will be able to identify different types of numbers in the real number system, classify numbers into their correct sets, understand the relationship between different number sets, and then apply this knowledge in everyday life. So first off, what are real numbers? Real numbers are any numbers that we can plot on a number line. Think of them as everything that you can see in real life and actually use. So whenever you're counting, keeping score of a football game, measuring the distances, how far you can run, or just calculating your GPA. All of those are real numbers. So, and these real numbers are broken down into different sets. All of these sets that we're about to go over are all part of the real number set. So the first set that we're going to go over is the natural numbers. So natural numbers are counting numbers. Everyone's learned this as a kid. You just go 1, 2, 3, 4, 5, all the way to infinity. So for example, hey, I scored 3 touchdowns. 3, that's a natural number. And the symbol that we use for natural numbers is an N, like a double N that has two lines on it. The next set that we're going to go over is the whole numbers. The whole numbers is very similar to natural numbers. As a matter of fact, every natural number is also a whole number, but whole numbers include 0. So for example, if you wanted to say we didn't score any points in this game, 0 is a whole number. And the symbol that we use for the whole numbers is just a W with double W. The next set that we're going to go over is integers. Integers are whole numbers and their negative opposites. So negative infinity, -3, -2, -1, 0, 1, 2, and 3. So for example, the temperature outside right now is -5 degrees. So we've determined that 0 is a fixed temperature of how hot it is, and it is 5 degrees less than 0. So that's how we get -5. And so the symbol for that is a double Z. And so you may be saying, hey, I understand where you got N for the natural numbers, W for the whole numbers, but where'd you get Z? Why do we use the Z for integers? Well, it actually comes from the German word Zahlen, which means numbers, specifically from the ganze Zahlen, meaning whole numbers or entire numbers. So German mathematicians uses this term, and so we've adopted it for the term of to represent integers. Okay, so the next number set that we're going to go over is rational numbers. So these are any numbers that can be written as a fraction. So A over B, where A and B are both whole numbers. The only caveat is you can't have a number over 0. So because anything divided by 0 is undefined. So you could have 1 over 2 or 0.5. Just because it's in decimal format doesn't mean it's not a rational number. So, and the decimals don't have to terminate. So for example, 0.333 on forever is just equal to 1/3, which is still a rational number. And so because it's a whole number divided by another whole number is a quotient. So the symbol we use is Q, like the double Q. And so the next number, or the next set of numbers that we're going to go over is irrational numbers. So that's where you're going to get your pi, you're going to get your square roots of 2, square roots of 3, and so on. So decimals that go on forever without repeating. And you can't write these as a simple fraction such as 1 over 3. So just because it goes on forever doesn't necessarily mean it's irrational. So keep that in mind. And so there's no single symbol for irrational numbers. However, what I've seen frequently is r minus the rational numbers. So that's one symbol I've seen. And so let's go over r. So r, that is just the symbol for real numbers. And so real numbers are all of these sets combined. It's the whole family. Okay. Okay, let's go and practice classifying different numbers. So let's start with 7. 7, is it a natural number? Yes. Is it a whole number? Yeah, absolutely. Is it an integer? Yes, absolutely. Is it a rational number? Yes, absolutely. We can write it as 7 over 1, which is equal to a rational number. And then if it's any one of these, then it's automatically a part of the real numbers. -4. Is it a natural number? No. Negative numbers aren't natural numbers. Is it a whole number? No. Negative numbers are not negative. Or whole numbers are not negative. Is it an integer? Yeah, absolutely. Is it a rational number? Absolutely. We can write it as -4 over 1, which means is a part of the rational numbers. Is it a real number? Yes. If it's any one of these, then it's a real number. Okay, let's move on to 2 over 3. Is it a natural number? No. It's not a counting number. Is it a whole number? No. If it's not a natural number, it's not a whole number. Is it an integer? No, it's not an integer. Is it a rational number? Yeah, absolutely. Look, it's a ratio right there. It can be 2 over 3. 2 and 3 are both whole numbers, and it can be written as 2 over 3. So yes, that means it's a fraction, so that means it's a rational number. And then since it's part of the rational numbers, that means it's also part of the real numbers. Okay, so square root of 5. Is it a natural number? No. Is it a whole number? No. Is it an integer? No. Is it a rational number? No. Is it irrational? Yes, it's irrational. So we can't write that as a fraction, so that means it's a irrational number. So and it is part of the real numbers. So let's go over a few common errors that I see quite often. So not all decimals are irrational. For example, 0.5 is rational, and you can write that as 1 over 2. That doesn't automatically mean that it is irrational. 0 is a whole number. So this means people forget that all the time, and they just think we're just talking about natural numbers, but 0 is part of a whole number. Negative numbers are natural or whole numbers. That's not true. So natural numbers and whole numbers are positive, or in the case of whole numbers, which includes 0. Number 4, not irrational doesn't automatically make it rational. For example, 0. 0 is not rational, but that doesn't mean it's irrational. So keep that in mind. All right, so pause this video and try these 4 problems, classifying them. Are they real numbers, rational or irrational? Are they integers, whole numbers, or natural numbers? Okay, so here are the answers to those questions. So be careful with number 3. So square root of 16 is equal to 4, which is actually a natural, whole, integer, and rational number. It's not a irrational number like the square root of 5. So be careful for tricks like that. Okay, so you might be thinking, when will I ever use this? Well, here's the thing. Understanding number types will help you know when the answers make sense. For example, you're calculating how many students can fit in a classroom. You need a natural number. You can't have 24.7 students. That doesn't make sense. But there are times when it makes sense where there might be like a half. So like if you're counting how many yards would gain in a play and he has 7.5 yards, that would make sense. So that would be a rational number, but not necessarily a whole or a natural number. So understanding these sets can helps you catch mistakes about when you're trying to use units to describe describe something. So, okay, so great job today. You understand the real number system, and you can classify any number you encounter. This foundation will be very helpful when you're understanding algebra and you're moving forward. So if you found this helpful, go ahead and hit the like button and subscribe for more math concepts. If you have any questions, please drop them in the comments. I'll read every single one and answer as many as I can. So until next time, I'll catch you later.